So this is managing your systems on Microsoft Azure with Chef. This will be a two-part presentation. So I'm going to start off with about the first half of this where we're going to go through some of that 100, 200, just talking about some of the common integrations, and we'll show some use cases for common scenarios with Chef and how those are leveraged within the existing Azure infrastructure, as well as some tools for both Windows. And it's going to be very fun to show off some of that Bash on Windows stuff and how it actually works with the Chef DK. So I'll be starting off here. My name is Paul DeCarlo. For whatever reason, the University of Houston allows me to be a professor, so you could call me professor if you want. You could also call me a senior software development engineer. That's my full title. So I work for Microsoft. A lot of the stuff we do, I work on our developer experience team. So we test out our emerging technologies, go around the world talking about it, build stuff, find things that are wrong, sometimes send that up to the product group, and sometimes we get stories told about the things we work on. So hopefully we'll have a good time today and not notice any new breakages or anything with some of the stuff we're going to show off. And feel free to tweet me at PJDeCarlo. And I do run a blog where I put a lot of weird stuff that we work on. A lot of my projects are usually fringe, like you want to play your Nintendo on your Xbox? Head to pjdecarlo.com. Hit my GitHub up. I'm Toolboc, Toolboc on GitHub if you guys want to check that. So we're bringing the cloud to Chef services. So Chef and Microsoft integrations are actually pretty straightforward. We have some built-in features into the Azure portal that you can leverage and some command line tooling that allows you to interact with common Chef clients, SDKs, and that sort of thing. And some of you might be familiar. We have tools that work on PowerShell, that sort of thing. We're also now seeing integrations in other products. We won't have time for this today, but Visual Studio Team Services would be one of those. I do want to take a moment and state that Microsoft actually uses Chef internally for a variety of different projects. The biggest one that probably everyone in this room would be aware of is the MSN. We actually do all of our MSN deployments internally using Chef, and that's like hundreds, if not thousands, of servers. And so we're going to start this off by talking about the thing that you guys have probably been hearing a lot about at ChefConf 2017, which is the Chef Automate platform. And as you guys are probably aware at this point, it's like your all-in-one shop for your Chef server, Habitat, application automation, and Inspect for compliance automation. So with that, I'm going to go ahead and shift off of the slides. We're going to walk into a series of demos demonstrating how you can get started with some of these features on the Microsoft platform. So first place we're going to head to, of course, is Azure. And this is one of those things that, like, if you've never used it before, you'll be like, how do I get to my services? And we should probably fix this one day. Up here in the upper right, where you can see my icon, that's a portal. We're going to go ahead and hop into that. And first thing you're going to see once we log into here is a dashboard that's going to show you all of the available features that we have deployed. So if you've used any cloud provider, DigitalOcean, AWS, it's going to be very, very similar to stuff you would expect. You can see the health of the Azure services and all that good stuff. And you might notice some familiar naming conventions here. My first node, second node, third node, fourth node. It took five nodes, I think, to figure this demo out. So with that, I'm going to go ahead and get started with where you can start with using the Chef Automate Marketplace image that we have just recently released about 2 weeks ago, I want to say. And this is a pretty cool image, not just because it's the familiar tool set, but it's also GovCloud compliant. So if you're looking to do things like in PubSec, that sort of thing, you can launch this image there. So first place I'm heading to, I just hit this plus sign on the left here. This is going to take me to the marketplace. You'll notice we've got a variety of offerings from Chef Software, Inc. And in addition to this Chef Automate image that I'm going to go into most detail today, you'll notice that the existing stuff all focuses on bring your own license or it has prorated license fees. The cool thing about the Chef Automate image, it is on a 30-day trial. So you can test out all the features of Chef within this marketplace image without having to go through any of that weird custom pricing or anything like that. And to deploy, I don't want to waste too much of your time here. You simply click it, create it, and that's going to go in and allow you to set up your FQDN, your DNS, all that sort of stuff. Just give it a public key, kick it over the fence, and then you're going to get something like this. So we'll go to my Martha Stewart already pre-baked Chef Automate server here. So let's imagine that we just deployed this Chef Automate Marketplace image. What is the first thing you do when you get a Chef server up and running? Probably want to upload some cookbooks, right? Sound good. So a nice thing is that with the Chef DK, there are offerings on a variety of different OSs. One of those includes Windows. I'll give you a quick demonstration because we don't want to hang out here too long. PowerShell, I can just hop in here. As long as I've got my keys, my credentials, which are given one time when you deploy a Chef server. Is everyone in the room familiar with that? I do want to make that very, very clear. You get one shot, one kill. If you do not get these keys and pull them down correctly, you cannot authenticate with that server. Good thing about cloud is you can deploy and destroy and start over again if you mess it up. But let's assume I've got these keys. Bam, I can call up our familiar tool, knife, and upload my cookbook right into that automated server. This is where things get sort of fun, in my opinion. If you're wanting to do live development, and maybe you're not really familiar with PowerShell and you want to go back to your popular Linux command line, this is Visual Studio Code, which is our cross-platform editor, runs on Mac, runs on Linux. It's built on top of Electron, and it also allows on Windows, if you've got the Bash on Windows tooling installed, you can set your integrated environment here to Bash. So if I wanted to do the same thing, I could hop into any of my Bash instances over here, and we can, again, upload a cookbook through Bash on Windows. So that's really nice. If you're using this as your operating system, you can actually go with your familiar feature set there and use Linux commands, essentially, on Windows. So what I like to do when I'm looking through this, I can go into my editor, look at my knife RB file, verify my client and all that stuff is set up and configured properly. What would be the next thing we might want to do once we've got a cookbook uploaded? Let's put some nodes up there, exactly. So we're going to look at another feature here that's offered through the Azure portal itself. And this is pretty cool. We call this the Azure Chef extension. And what's nice about this, it is open source. So if you see any problems with it, you can fix them. You want to fix stuff, you can file issues, all that good stuff. And if you want to head to that link, you can just head over to, I got a short link for you. Wow, that's hard to read with lolcat, but aka.ms/chefex for those of you that might be interested in taking a peek at that source code. But we'll show you what this looks like in practice. So this supports a variety of different operating system images. Similarly to how we deployed our image earlier, I can head back over here, select we'll just go to see all. We should see some good stuff here. Or go to compute. And you can deploy this onto Fedora, Debian-based servers. It also works on Windows Server as well. And I'll show you what this looks like with a quick demonstration Ubuntu deployment. So go ahead and select 1604 LTS. Go ahead and create. We're just going to do some boring stuff real quick for a moment here. I'll go through my, what should we call this? I don't know where we're at yet, so maybe we'll call it 7th node. Pretty sure I haven't done that yet. And it's a cool little trick. Obviously, you're going to get better performance in Azure with SSD, and that is your default choice in the portal. I'm going to go ahead and select old-fashioned HDD spinning disks. And the nice thing about that is if you're using test environments, those services are a lot less expensive, so you can get those out on a budget. And I'm going to go ahead and be weak and set up a username with a password because I don't have my key. And make sure those match. We're good. I'm going to go put that on Tim's subscription. I know you guys can't see that. Let me go ahead and zoom in. I am not Tim. Tim can deal with this bill. All right. Tim's a good guy, don't get me wrong. So we'll go ahead and set that up. And our second, this is one of those just common things on a cloud platform, but I'll show you a cool trick if you're on Azure. Again, notice that I selected that HDD. It does kind of want to give you some good machines by default, but if you want to be on the cheap, you can head on and select View All, and you can get all the way down to like a single core, maybe 1.5 gigs of RAM machine, and run that for $20 a month, maybe less. Let's see what we get here. All the way at the bottom, that's where I shop, the bargain bin. So let's head down here. It's my life. Okay, here we go. Single core, yeah, $18, $18.60, right? So we'll go ahead and select that. Now this is where the magic happens when we're talking about that Chef Azure extension. Here you'll notice, boom, we've got an extensions setting here. I'm going to go ahead and expand on that. And if I click Add Extension, we're going to get a bunch of options for various different things. And here we get the Linux Chef extension. And this is interesting because, the settings seem obvious, but you always want to kind of double check with that knife RB file. So the first thing it's going to ask me for is your chef server URL. And you might be convinced like, oh, that's my top level domain. It's always resolved with the organizations extension, at least for Chef Automate deployments. So I'm going to go ahead and do, I can head into my VS Code. And I'll grab from my knife RB config the chef server URL. We'll go ahead and pop that in here. This is going to be my 7th node. And then for the run list, this is using just your normal syntax that you would have when upload or setting a run list for any cookbook that you might be familiar with. So I'm going to go ahead and use that. I don't know if I showed you guys this, but just FYI, our cookbook we uploaded, we got one of those basic run in Apache 2, right? So we'll do like a quick hello world, something to that effect. You guys have seen that demo, right? Over the last couple days, I would hope so. So we'll go ahead and what is this syntax here? Recipe, open bracket, ChefConf. And I'm going to set that to run that Apache 2 recipe. And then the validation client name. Again, I know this because the way it's set up, but you can always double check that here in your knife RB file. I've got, it's called MSFTValidator. Okay, so matching my org there with MSFT. And then for my validation key, this again comes with that one-time download when you set everything up. I want to stress that. Just one time you can get those keys, right? So we're going to go ahead and select that MSFTValidator. And everything else I'm going to just leave. I'm not going to do a special client config, and I'm going to turn SSL verification off. And this is pretty much everything we need to make that call in and execute a run list based on an existing Chef server. And that doesn't have to use the marketplace image. That can use any existing Chef server that this has a route to communicate to. So go ahead and click OK. And this is the fun part here. I really like this piece. We're going to go ahead and get everything right to the step where we're going to click the deploy button, right? So it's going to go through this running final validation. And this is an Azure specific feature here. So you see over here on the right next to my OK button, it says download template and parameters. So I'm going to go ahead and click on here. And you'll see that this gives me this JSON payload here that essentially describes this deployment. And we refer to this as an ARM template. And what's really cool about this, you can add these to a custom library and sort of invoke them anytime that you need to call on them or use them, which is nice. There's command line tools that'll let you go, ping that on a URL. You can also go in here and set parameters. So maybe you want to deploy something, but you want to change a specific feature here and there. And if we were to scroll through this, I believe down here near the bottom, oh, yeah, there we go. There's that validation key in plain text. You guys start jotting that. You'll see my client name and all those parameters that we've set up before. So this is cool stuff. It allows you to sort of lift and shift using infrastructure as a code, an ability to define what perhaps your deployment looks like. And you can also change key variables and parameters within there. In fact, those can support things like CLI, and it'll actually give you sample code for that. Also our CLI 2.0. If you're a PowerShell pro, go ahead and jump in with the PowerShell example. Even .NET. I thought this was kind of cool. You could write a .NET client. And if you're crazy, you could write like some ASP.NET Core while you're in Bash on Windows and just like melt your whole mind because you're like, whoa, I can't believe you can do that now. What happened to Microsoft in the last 2 years? And then Ruby, again, which everyone's probably familiar with since this is a ChefConf, right? And that's where everything happens. So once you've got all that set up, you can download it, take a peek at it. That's usually what I'll do. I'll download it, and if you want to modify the template, head into your favorite template editor, and you can go ahead and take a peek. And from there, all I have to do really to deploy this node out at this point is click our OK button, and there we go, right? We're going to go ahead and get that thing sent out. So there's your ARM templates. Now, this is probably one of my favorites. I love that Chef, the entire ecosystem, refers to everything using terms that have to deal with kitchens, cooking utensils, right? So we've got supermarket. We've got Knife Azure. I like that one. Very, very interesting. And again, Knife Azure is a plugin on top of Knife that can allow you to, if you want to avoid all of the things that I just showed you in the Azure portal, you can go ahead and use this extension and do all of that deployment or even invoking ARM templates that we just showed from the command line. So this gives you a lot of cool power in terms of scripting, if you want to build out, tear down, all that good stuff. And all you have to do to use it is execute a particular series of commands. Let's see if I can pull that up, because there's no way I'm typing that again. Yes, it would look something like this in this case. I'm just using a very, very long one. So essentially what I'm doing here, I'm telling Azure RM that I want to create a resource group, naming a VM, telling it where I want that VM to go, referencing an Azure image. In this case, I'm using Ubuntu Server 4.04 2 LTS, and setting a password and setting a VM size. And then we're doing a few things here that'll just modify the client config once that gets sent over. And so if you are curious, all this stuff ends up in opcode client RB, I believe is where the config ends up getting written to. So if you did want to see that at the end of the day when that goes up. And if everything is all good after our deployment here, we should have an active node. It's not the most exciting demo, but our yeah, there we go. We've uploaded our cookbooks 3 times in the past 12 hours. There's our total nodes. We should see 7th node come up here any moment now. It's still provisioning at this point. But that's really all I've got for kind of the 100 and 200. I'll take a quick question, and then we'll swap out, because I'm going to have David Justice come up here. He's going to talk about some other exciting features involving Azure and Chef tools. So yes.
The extensions that you're showing, is that the same with parallel with the artifacts and dev test labs?
I'm not familiar with dev test labs. David, do you have feedback? I know this is going to be hard to read on these monitors here, but both of those open source tools, if you did want to check those out, you can go to aka.ms/chefex and then aka.ms/knifeaz if you wanted to check those out in person. And if you want to come up, David.
All right. Hi, everybody. Hello. Hello. I'm David Justice, and I build code for Azure and get paid to write open source software by Microsoft. That's a really weird thing to say, and I'm so happy about it. Let's see. Let me get this set up. So we're going to have a few slides here, but we aren't going to spend too much time in slides. Let's see. Here we go. Okay, so what I'm going to show you today is we're going to build out Azure Container Service infrastructure using Kubernetes in Azure Container Service. We're going to build out a registry for our images, and we're going to then deploy out a Habitat Rails application to Azure Container Service. So I think this is going to be a lot of fun, and hopefully it all works. All right, so ACS. So Azure Container Service is really awesome. I am really excited about it because it is a mixture of multiple different orchestrators. We get, you can use DCOS, you could use Kubernetes, and both of these provide us the ability to deploy containers or run orchestration on Azure. We deploy these with our ARM resource provider. So basically, it comes as a template. You can customize this template if you want, but really you can be pretty much hands-off on it, and you'll see what that looks like as we move into it. Now, it's kind of interesting. We have 2 different routes in ACS. We have Kubernetes and Mesos. That's to give the freedom to be able to say, okay, we also have, Docker Swarm as well. But it gives you the freedom to be able to build your application on what you want to bring to the cloud, not necessarily locked into any one orchestrator. So you end up saying, okay, I know I want to use Kubernetes. I'm going to use K8 in the cloud on Azure. Or you can say, I'm going to use DCOS. Either one gives you your standard APIs, it's not sticky. So I want to make sure that what we want to hit is open source, not sticky, and you're able to come and go as you please. So part of that is being able to contribute to ACS directly. So you can go out on GitHub and work on the container engine itself. It's completely open to you, and you can add to it as you like. So one of the other things that I work on is Azure CLI. And we're going to use this today to build out our container infrastructure. In here, we just actually introduced a new Azure CLI. Azure CLI 2.0 is based in Python and is a much more friendly, scriptable command line. Has anybody in here tried Azure CLI yet? Better, worse, last one? Yeah, I don't spend too much time in the UI, so I'm glad to hear that. All right, so it's Python modules. Please feel free to contribute if you'd like. You could add your own modules if you want. They're just pip installed. It's pretty straightforward. Also on GitHub, Azure-CLI. All right, so you can log in with two-factor auth, or you can use a service principal to log in. Anybody familiar with Azure probably has gone through those steps. Not always the most fun, but we've tried to make it better in CLI 2.0. All right, cool. So there's output formatters. We get table, JSON, TSV. These are one of the feedback items that we got from CLI was that output formats were just gnarly and inconsistent. They were hard to program against. So we made sure that we nailed those down in this rev. So if you're getting TSV, parse it just as you would any other TSV output. Likewise, default is JSON. So also added in James path querying, so you get more powerful querying. The ability to then rip into those JSON structures that you get back from the services. So let's actually get into code because that's where it's more fun. So we have Habitat and our container service. Let me drop this show off. All right. All right. The cow always says something. All right. All right. Can everybody see that? Oh, that is way too small. Bright in the background? Okay. That's still not going to be good, huh? Okay. Yay? All right, good. Sorry. All right, so all right, let's take a look at our app real quick. Okay. So. All right, we're just going to kick off a Rails server real quick, and we'll see exactly what it is that we're going to build. Oh, I miss iTerm. Okay, so what we have here is a to-do app. It's to-do list, pretty standard. Ember front end, Rails back end. We're going to put together this app, and we're going to deploy it out using Habitat onto Kubernetes. As you can see, it's calling back to Mongo here to go fetch those objects that we saw. We have Mongo running localhost right now. We're going to use Cosmos DB an Azure database, globally scalable. We'll get into it a little bit later. But basically use the same Mongo wire format and just swap out connection strings and have our service up and running. All right. So I'm going to kick off our provisioning. And I'll get into the provisioning script after it's run. And at the same time, I'm going to start our Habitat build, and then we'll dig into some of the code. Habitat is fantastic and allows us to abstract whether we're deploying out to a VM, a container, whatever it is that we want to deploy out to. But it does take a bit to build out our Habitat containers, or hearts, excuse me. So let's see. So our provisioning script went through. It built out a resource group, Habitat K8s. It is using a asymmetric key that put together and dropped for this use. Created a Cosmos DB. It built a Kubernetes cluster. In that resource group, it built a container registry. It logged into Docker for that container registry. It created credentials to manage the cluster. It's registered secret key so that the cluster can reach out to the container registry. And it's now ready to use the Kubernetes cluster. So here's our Kubernetes cluster running. We just asked for cluster info from kubectl. In this script, if you did not have kubectl, it actually pulls it down for you. And let's take a look at what that script actually does. So going to set up basically some variables. Then we're going to check if we're logged in. If we're logged in, OK, just pass. Next, then we're going to go and build our resource group. A resource group in Azure is a logical grouping of resources. So your resources being a container service, a storage container, perhaps a collection of VMs. Then we go through and generate SSH keys and build out the Cosmos DB. So this is kind of cool. We go and say, hey, AZ, create me a Cosmos DB. And I want you to use the Mongo wire format for this Cosmos DB. And then AZ creates it. And here we're creating the ACS container service. And we're specifying to use the Kubernetes orchestrator type. So this is kind of fun. We have this container service that we can provision, tell it how many agents we want, tell it how many masters we want, what type of orchestrator we want it to use. We have almost absolute freedom here. That to me is really powerful. If you want to run large-scale data analytics on Mesos versus I want to run a bunch of containers in my cluster using Kubernetes, this gives you that ability to do that rather seamlessly. And then eventually we're going to go and build a container registry. And we'll come down and use that container registry, do a little bash nonsense, and log in with the username and password. All of this, again, done with Azure CLI. Finally, getting our Kubernetes credentials through Azure CLI and building out, installing kubectl in case we don't have it. So we've tried to make it as simple as possible. You can get all of the tools that you need through CLI to make sure that they work together and build out these clusters. Eventually, getting to the point where we create our Docker registry from the password and username within a registry and register that with Kubernetes cluster. OK, cool. So let's see. All right. Well, our HAB plan has built. So why don't we go back to the HAB plan, and I'm going to go and export it to Docker. All right, so it's going to go, and it's going to take that heart that I just built, and we're going to export that heart to Docker, to a Docker image. And we're going to use that Docker image to then push it up to the container registry. So we can use that container registry to then feed into our Kubernetes cluster. Does that make sense? It's kind of a lot of moving parts. But as you can see, we're spinning up our Docker engine right now, and we're creating that container image. And when we get done with that, we can actually exit out of Hab Studio. And we could say, OK, Docker images. And we can say, we just built our Rails to-do. And it's tagged with latest. So what just happened there? All right, so here's our Hab plan. Our Hab plan is where all this stuff kind of kicks off for Habitat. So our Hab plan, we're going to describe all the things that we need to create this immutable piece of infrastructure that we're going to deploy out. So we're going to use Ruby. We're going to have our CA certs. We're going to use Bundler. We need core utilities, OpenSSL. And then we need some stuff to build up perhaps native gems. So GCC libs, that kind of stuff. And then we're going to expose out our ports. So this one is just going to be port 3000. The rest of the build script goes through and builds out, does a gem install, and then ends up creating bin stubs and replacing the core utils user bin env in the bin stubs to point to core utils within Habitat. Another nice thing about Habitat is we get configurations and configurations that can be baked into those images and then replaced with values that we've specified in our configuration. So when I'm moving from one environment to another, there are little pieces that I want to change out. And one of those would probably be a connection string. So in here, we're actually replacing the connection string for MongoDB to be our cloud connection string. And I'll show you that in a moment. And final pieces are the init and the run. So in this init, we're linking in our configurations. And you can see we're linking them into from the config path into where the service actually lives in the Habitat package. Habitat provides a lot of variables for you to map from individual file paths within the Hab environment into whatever paths you need for runtime. That's a very good question, and I cheated there. I will own that. Yeah, that's actually a really tough question. How do you bootstrap secrets, right? Another day. Okay, so load paths, and then eventually we get to the point where we're kicking off the Rails server. Probably not the nicest way that you want to run Rails in production, but we'll just do it for demo purposes. So as you asked, here's our rockstar secrets. They're in our default toml right now, which you shouldn't do. But I didn't want to get into secrets because we only had 20 minutes. So bingo. And we have our container, and we're going to go and give it a quick run. Let's see here. So actually, let's just push it out. So we're going to tag it. So we'll tag that container, and then we're going to give it a push out. And right now, we could run this on our local instance of Docker and just say run on map in port 3000 to 3000, and we'll run, and it'll be run just like it was in production. You can do that within Hab Studio. You can have tight iteration, tight loops there, and it's actually quite a pleasure to develop in. All right. So while that's deploying, let's take a look at the infrastructure that's built. So here is all of the VMs, network, load balancer, Kubernetes. All of our infrastructure was built by just those handful of commands. And we have a full Kubernetes cluster running. All right, cool. We pushed that out. Now we're going to go and run in Kubernetes our image. Okay, so we just created that image. Let's see. It is now creating the container. It is pulling down the container image into Kubernetes, and it is running. And now we're going to go and we're going to expose this publicly. All right. So what happens now is Kubernetes is going to talk to the Azure network fabric, our software-defined network, and it's asking it for a public IP address. That public IP address will return, and it'll be provisioned. And what we're going to do is we're going to watch. So you can see it's pending right now. This can often take a few minutes. So while this is going on, I want to talk a little bit about Cosmos database. So Cosmos DB, all right, let me blow that up. So Cosmos DB is really cool. It is a globally scalable database. So has anybody in here run a Mongo cluster? Anybody been? Is it a fun experience? Do you recommend it? If you don't want to do that, you can just as easily spin up a document or Cosmos DB cluster using the Mongo wire format. Cosmos DB offers throughput, latency, availability, and consistency guarantees for the 99th percentile. Reads are guaranteed to be for the 99th at 10 milliseconds. Writes are at 15. You can control consistency similar to Cassandra. You can set up whether or not you want serializable writes within a given session. You want serializability within an entire region, or if you want eventual consistency. So you can turn the dial as however you want. It also allows you to do some really, really cool stuff, like replicating your data across the entire world by just hitting a few of these and watching them stack up as write regions and read regions, which will automatically fail over if your write region goes down. So your connection string is still good. It's a replica set that'll end up getting forwarded onto the proper region. Again, if you don't have to, if you're able to not run this stuff, let us do it for you. We'll handle the creepy stuff. It makes it a lot easier. So cool. Yeah, I'm going to discard those because I don't want to get charged as much as Paul over here. All right, so that's all of our infrastructure. And let's see, is this, it's still pending. So let's see, while this is still pending, are there any questions so far? Yes?
So with the secrets management, not having used Azure CLI or Habitat, could you use like Azure Key Vault in your Azure CLI plan to like grab it and then pull it down and pass it on?
Yes, absolutely. That's a great point. So the way I like to do that is I like to use Key Vault. I like to create a certificate in Key Vault, and then I will take the public side of that certificate, bring it down, and I will create what's called a service principal with the public side of that certificate. From that, I will use the certificate in VM creation. So I will use, it's called the certificate is also synonymous with a secret. So you can provision that secret onto the VM machine when you build it, or a VM scale set if you're going to autoscale. What that does is it drops the public and the private side of that certificate onto that VM, and you can put those two together and actually auto-authenticate a Azure CLI session. So from that, you could then access any other secrets or use the management libraries from that VM. So you basically are provisioning an identity onto that VM. I have code for that. If you would like to see it, I'll share it with you afterwards. I actually just wrote a post about that. So if things work this should work. All right. All right. So to your point, here I could show you that code. Did it with the same application, and what I wanted to do is make sure that when I was reaching out for the keys with that application, it was only after it was provisioned onto the machine, and that machine could reach out with its identity. So if you look at this cloud init, this cloud init actually goes through and, let me blow this up a bit. The cloud init goes through and ends up catting two PEMs together, the public and private, and then ends up tossing it into the deploy users folder and logs in with the service principal using tenant and, username and certificate. That mixed with this provisioning script, where it's creating the key vault certificate, creating the service principal, and then eventually creating the VM scale set using this VM secret.
Would that be the most secure way to go about it in terms of like handling those secrets?
Okay, from a DevOpsSec, you end up with the certificate never touching a development machine, only staying in the production environment, and then you can lock down the service principal to be exactly what services you want to access. It's very similar to IAM roles. So in my mind right now, that is the best. We are always advancing that, and one of our big focuses is on security and making that story better. Precisely. And that actually happens. So we use RBAC there for key vault right here. So key vault set policy for the vault name. And then I get the object ID for the service principal. And I say, OK, service principal, you only have access to request secrets from this key vault. You can't make certificates. You can't write new ones. You can just have access to this small set of secrets. You can also do that with RBAC roles, saying you have only access to these services. Does that make sense? Yep. You're welcome. Any other Azure questions or talk about the weather? If anybody has any questions, please reach out. David Justice on Twitter, Divine on GitHub. Happy to talk code or business. Cool.